This is Calculus with Allenson. We're doing problem 4 from the Form B version of the 2006 BC test. A asks us to find f prime of 22. So we're looking straight to the graph, and the graph of f, the slope of it would be f prime of 22, and the slope at 22 is equal to -3. It asks for the units. And since f is calories per minute, the slope is calories per minute squared. B says during the time interval 0 to 24, when is the function increasing at the greatest rate? And there's only two times when it's increasing. One is between 12 and 16, and the other is from 0 to 4. And so the slope is 15 minus 9 over 16 minus 12, which is 3/2. Okay, and it's 3/2 on the entire thing because it's a straight line. On this one, there's a function for it, so it's the derivative of that, which would be -3/4 t squared plus 3t. Okay, so when is it increasing the fastest? So when is this going up by the most? And so I'm going to take the second derivative, and I'm going to get -3/2 t plus 3 equals 0. That happens, subtract 3, multiply by -3/2, we get t equals 2. This is where the slope has a maximum, where f prime has a maximum. Okay, so the reason is because if we go where the second derivative is greater than 0, that happens as long as I'm from 0 to 2. Once I get to 2, this becomes -3/2 times 2, which is -3 plus 3, which is 0. But before that, this right here is not as powerful. It's less than 3 essentially, and so it doesn't get up to 0, it's negative. When f double prime is less than 0 is after 2, so from 4 on, or from 2 on, sorry, from 2 to 4, and this one's from 0 to 2. Okay, so C says find the total number of calories burned over the time interval 6 to 18. Okay, so 6 to 18 is kind of an odd grouping, but 6 to 12 is all a flat line. So that's a width of 6 and a height of 9, or 6 times 9, plus the next section's a trapezoid from 12 to 16. So the trapezoid would have a height of 4, and the bases would be 9 and 15. And then the last section from 16 to 18 is flat, so it's a rectangle. 16 to 18 is 2 times the height of 15. And you get 132 calories. D says the setting on the machine is now changed, so the person burns f of t plus c calories per minute for this settings. Find c, so that an average of 15 calories per minute is burned during the time interval 6 to 18. Okay, so we know 132 calories were burned from 6 to 18, and we want to add something to the function so the whole function slides up, so that we get something that would average 15 calories. This, I'm not sure what this would average, but it's from 6 to 18, so it's 12 minutes. So I could divide this by 12. 132 divided by 12 is actually 11. So right now we're at 11, and we need to get up to 15 for an average. So if I'm dividing by 12 and I want to get up to 15, then what I'm looking for, basically I want to have an average value So 1 divided by 12 of the integral of 6 to 18 of f of t plus c, and I want that to equal 15. Okay, I essentially have the same thing here. This is the integral from 6 to 18 of just f of t right there, and it was 11. Or I mean, it was 132, and then when I multiplied by 1/12, I got 11. So I want to see how much I have to add here. I know that I have to add 4 to this, but I'm going to be dividing by 12. So in this spot, what happens is if I add 4 here, it gets added up every single time. So that's why C ends up being 4. Points for this one. A, 1 point. -3 calories per minute squared. You need the units. B, 1 point for f prime of t from 0 to 4, which is right here. Needs to be that. And you need to show that f prime has a maximum at t equals 2. You need to show that this derivative right here from 12 to 16 is actually that 3/2 is less than 2. So you can see we've done it, so that shows that we would have chosen it if it was bigger. And then the answer of being that it's increasing the greatest at t equals 2. So maybe I should have circled that. C is worth 2 points, one for the method of finding all those areas of triangles and trapezoids and rectangles or whatnot, and 1 for getting 132 calories. For D, 1 for the setup, and 1 for getting that C is equal to 4.